I'm in a clean room right now in Northern California with the world's largest digital camera. Now, this camera right here cost about $6,000. This one behind me, $168 million. And we're getting an incredibly rare look inside because the lens cap is off, so we can see all the instruments and all the sensors. You've heard of Hubble, and more recently James Webb. Now get ready for the next incredible telescope expected to discover billions of new stars, uncover millions of new objects in our own solar system, and fundamentally change the way we see the universe. This camera, the size of a small car, is the centerpiece of the Legacy Survey of Space and Time, or LSST, a 10-year project to map the entire southern sky in incredible detail. Just how much detail? This 3,200 megapixel camera is so powerful, it can spot a golf ball 15 miles away. When the decade-long project is finished, scientists will have produced a 3D movie of the sky. One that shows how all the trillions of objects captured move relative to one another, how light bends around massive objects, and how individual solar systems and galaxies developed over billions of years.
This movie that LSST will enable, it will see things on timescales that haven't been accessible before. So we expect we might detect, new classes of stars or supernovae or other kinds of explosions.
Once finished, the LSST camera will be the heart of the Vera C. Rubin Observatory in the mountains of northern Chile. Here, at the SLAC National Accelerator Laboratory near Stanford University, scientists are putting the finishing touches on the camera. This has been a long process, more than 2 decades.
I don't think we have any other cameras quite like this in the visible spectrum that are certainly not as large as this.
Travis Lang is one of the camera's lead engineers. He's been on the project 8 years.
It's been a lot of fun, a lot of challenges, a lot of issues that come up along the way. We only have one, so we don't get that opportunity to have things of scale. So we have to figure it out as we go.
Just like the camera on your phone, on the LSST camera, it all starts with the lens. But this camera being 13 feet long, the lens is a whopping 5 feet across. That's a Guinness World Record, by the way, and it took 5 years to construct. After passing through the lens, the light hits one or more of 6 filters, each optimized to collect light from a specific range in the spectrum, from ultraviolet to near infrared. Once the light is filtered, it hits the focal plane, which captures the image. The focal plane is made up of 189 individual sensors, blocked together in groups of 9 to form what's called a raft. This time-lapse video shows the camera team assembling the 25 rafts that make up the focal plane over a period of 6 months. At $3 million per raft, and gaps between them less than 5 human hairs wide, it was a delicate process, but it worked. Scientists tested the focal plane last year and produced these images. This, by the way, is a head of Romanesco broccoli. Now here in the back, you've got about 110 feet of cables and hoses to power the system and to move coolant and water to keep the system operating at the correct temperature. That's because the camera generates a lot of heat, about 10 times more, in fact, than early astronomical cameras. And the focal plane needs to stay around minus 100 degrees Celsius to operate at peak performance. Once in operation, the telescope will capture a piece of the sky 3.5 degrees across. That's 7 times the width of a full moon. Using this massive shutter, the camera will take back-to-back 15-second exposures, then read that data out for about 2 seconds before moving on to the next section of sky.
When we read out and it's in 2.3 seconds, well, it generates about 12 gigabytes of data. So it's about 6 gigabytes a second.
When we see a new phenomena occurring in real time, we are going to send alerts. So within 60 seconds of the shutter closing on the focal plane, we are going to be able to send alerts to anybody who is curious.
That means all of us will be able to scour LSST's 10-year movie and make our own discoveries. But it's scientists like Risa Wexler that are particularly starry-eyed about what's coming.
We expect to detect 17 billion stars in our own galaxy. We expect to find really small, the tiniest galaxies in the universe that are really, really nearby. And we expect to find galaxies 13 billion light years in the past.
And it's not just the new planets, stars, and galaxies that has scientists excited. They expect LSST to give them new insight into scientific mysteries that have so far gone unsolved.
It enables such a big diversity of questions. It enables us to ask really big questions what is the universe made of, what is the nature of dark matter and dark energy. But there are also a whole bunch of discoveries that this should enable that we don't even know what they are.
So once they put that lens cap back on, the LSST will undergo a series of testing for the next few months before it starts that long journey down to Chile in May. Now, once it arrives at the observatory, installation begins, LSST is going to go right there. So I want to know what you think. What excites you most about LSST? Let me know in those comments down below. If you enjoyed this video, please don't forget to give it a thumbs up and subscribe to CNET for more like it.